Imagine this, a fast-moving object, the size of Manhattan, is hurtling toward our solar system, and it's going to make its closest pass to Earth on December 17th. Picture yourself waking up, still half asleep, grabbing your morning coffee, and scrolling through the news, and suddenly, every headline is talking about the same thing. Every major network shows the face of renowned physicist Michio Kaku, his expression heavy with concern, repeating one chilling word over and over, terrifying. At first glance, it feels like the start of a sci-fi movie trailer, some new summer blockbuster about a cosmic disaster. But this isn't fiction. This is the reality of 2025, and that headline is tied to a shocking new data release about a mysterious interstellar visitor, the third ever detected by humanity, officially named 3I Atlas. In the last few weeks, something extraordinary has been unfolding quietly behind the scenes. Across the globe, from Chile to Hawaii to Japan, telescopes have abandoned their regular programs. Even the mighty James Webb Space Telescope, humanity's most advanced eye in the cosmos, has pivoted its focus. Every spare radio dish, every high-powered lens, is now pointed at one faint streak of light moving silently through the darkness. What could possibly demand such a unified, urgent response from the entire scientific world? The answer isn't just its speed, though that alone is jaw-dropping. It's that this object's chemistry and motion appear to defy everything we thought we knew about how the universe works. When Dr. Kaku addressed the press, his words were stripped of his usual optimism. He said, "If these numbers hold, we're looking at something that did not form in any environment we currently recognize as possible. The implications are staggering." And he's not exaggerating. Because what scientists are seeing in the data isn't just strange, it's rewriting physics as we know it. So how did this begin? Let's trace it back to the exact moment the discovery was made. On July 1, 2025, at precisely 2:14 a.m. Universal Time Coordinated, the Atlas telescope in Chile, part of NASA's Asteroid Terrestrial Impact Last Alert System, flagged something unusual. The system is designed to scan the sky for objects that might threaten Earth, a sort of early warning shield for potential impactors. But this was no ordinary asteroid. It appeared as a faint point of light, no brighter than a 19th magnitude star, a ghostly dot barely distinguishable from the cosmic background. For perspective, the brightest stars in the night sky are around magnitude 1, while the human eye can barely detect anything dimmer than magnitude 6. This object was thousands of times fainter, nearly invisible, even to the most powerful amateur telescopes. Within 24 hours, the Minor Planet Center, the global authority on such detections, issued a circular that sent shockwaves through observatories worldwide. The new object's orbit wasn't bound to the Sun. It was on a hyperbolic trajectory, meaning it was just passing through our solar system and would never return. Even more astonishing was its inbound velocity, 58 kilometers per second, or about 130,000 miles per hour. For context, our fastest spacecraft, Voyager 1, crawls along at roughly 17 kilometers per second. Atlas was moving more than 3 times faster. That's the kind of speed you'd expect from something ejected from a massive star system, not a rock casually drifting through space. Atlas officially became the third interstellar object ever detected, after Oumuamua in 2017 and 2I Borisov in 2019. But unlike them, Atlas is bigger, brighter, and far more mysterious. Its sheer speed, 137,000 miles per hour, means it's covering over 58 kilometers every second. That's roughly 55 times faster than a rifle bullet. If Atlas had been fired from New York at the same moment a bullet was shot, it would cross the entire continental United States and reach Los Angeles in the time it takes to count to 90. The kinetic energy it carries is almost beyond imagination. Had its path intersected Earth, it could have unleashed the power equivalent to a continental-scale catastrophe. Thankfully, every trajectory calculation confirms it will not collide with our planet. But even so, the discovery left scientists reeling. The next question became, where did that incredible speed come from? Typically, such high velocities are achieved through gravitational slingshots, where an object gets flung outward after passing close to a massive body like Jupiter or a star. But when researchers traced Atlas's trajectory backward into deep space, the results didn't add up. There was no nearby star system, no binary pair, no dense stellar nursery capable of accelerating it to such extremes. It was as if this object had been launched from a cannon that doesn't exist. And that's just the beginning. When the James Webb Space Telescope analyzed Atlas's chemical fingerprint, it found something even more baffling. Its composition was utterly alien. The data showed it was rich in carbon dioxide but contained almost no water ice, which makes no sense by our current models. Comets in our solar system are dirty snowballs, made of roughly 50% water ice by mass. But Atlas? Less than 5% HO. Instead, it's dominated by Co, making it unlike any comet, asteroid, or known body in our cosmic neighborhood. Even stranger was its carbon isotope ratio, a sort of molecular signature that reveals where an object was formed. Atlas's ratio was nearly double the baseline of our solar system. Statistically, that's no fluke. It's a cosmic birth certificate from a place unlike anything we've ever observed. Dr. Kaku summarized it starkly: either this object formed in a carbon-rich protoplanetary disk around a much hotter star, an environment we've only ever theorized about, or its chemistry was somehow altered by forces or processes we've never witnessed. Both possibilities, he added, would upend everything we know about how planets and comets form. But what truly made scientists lose sleep was the third anomaly. Despite being on a hyperbolic trajectory, meaning it's unbound and simply coasting through our solar system, Atlas isn't moving exactly how gravity says it should. There's a faint, persistent acceleration, a tiny but measurable push that doesn't fit any known model. After accounting for the gravitational pull of the Sun, Jupiter, and every other major object in the solar system, something was still nudging Atlas forward. This isn't unheard of. Comets can experience non-gravitational acceleration when sublimating ice jets act like miniature rockets. But with almost no water ice detected, the math doesn't work. The measured thrust is far too strong for the limited co-outgassing observed. That's when Harvard astronomer Avi Loeb, known for his bold theories about Oumuamua, published an intriguing idea. What if Atlas isn't a rock at all, but a light sail? A paper-thin, lightweight structure propelled by sunlight itself. The acceleration pattern fits. Dr. Kaku didn't outright agree, but he didn't dismiss it either. In his press slides, he ended with a chilling statement: we cannot rule out a Type 4 probe scenario until we rule out every natural one. And right now, we can't do that. For context, the Kardashev scale classifies civilizations by their energy use. Type 1 civilizations control their planet's energy. Type 2 harness their star. Type 3 control an entire galaxy. A Type 4 civilization, theoretical but terrifying to imagine, would command the energy of the universe itself, bending physics at will. The suggestion that Atlas could be a probe from such a civilization sounds like science fiction, yet no one can disprove it at this moment. So when Dr. Kaku says the situation is terrifying, he doesn't mean Earth is in danger of collision. Atlas will safely pass near Venus's orbit on July 28, then disappear into the void forever. The fear is existential, not physical. If its speed and chemistry are real, it proves there are regions of the galaxy forming objects utterly alien to us. If its acceleration persists, it could mean we're witnessing technology not born of nature, but of intelligence. Either way, the discovery reshapes humanity's place in the cosmos. In the coming days, every major telescope on Earth and in orbit is racing against time. The window to study Atlas in detail is closing fast. Just 72 hours remain for high-resolution observations before it fades into darkness. After that, we may never get another chance. Whatever data humanity collects now could become the foundation for a century of speculation, research, and wonder. And when it's gone, all that will remain is the uneasy realization that the universe may have just handed us an exam far beyond our level of understanding. One we are nowhere near ready to take. So for now, stay curious, keep looking up, and if you have a telescope that can still see Atlas, point it skyward. Because history doesn't often give second chances, and this might be the one moment that changes everything we thought we knew about the universe.